Privacy principles and international frameworks. The foundational privacy principles such as the Fair Information Practice Principles, FIPPs, and the OECD guidelines provide a baseline for privacy practices worldwide. These principles emphasize transparency, accountability, and user control over personal information. They set the stage for regulatory compliance and help organizations build trust with their stakeholders. Adopting privacy frameworks. Frameworks like the NIST Privacy Framework, ISO/IEC 27701, and BS 10012 provide structured methodologies for managing privacy risks. These frameworks guide organizations in creating, implementing, and assessing privacy policies and practices that comply with legal and regulatory requirements. They are crucial for developing a robust privacy management system that aligns with business strategies and technological architectures. Theoretical insights into privacy. Exploring theoretical models such as Helen Nissenbaum's contextual integrity and Ryan Callow's harms dimensions enriches our understanding of privacy beyond compliance. These models advocate for a nuanced consideration of context and the nature of harm, respectively, which can help technologists design systems that respect user expectations and mitigate potential damages from privacy breaches. Risk management in information privacy. The Factor Analysis in Information Risk (FAIR) model provides a quantitative approach to privacy risk assessment. By evaluating the likelihood and impact of risks, organizations can prioritize resources effectively and enhance their risk management strategies. Privacy by Design Principles. Operationalizing privacy by design. Privacy by design, PBD, is not just a policy but a proactive approach embedded into the lifecycle of IT systems and business practices. It involves ensuring privacy from the initial design stages through to the final stages of the data lifecycle. Principles such as embedding privacy into design, ensuring full functionality, and maintaining transparency are integral to PBD. Part C, Privacy-Related Technology Fundamentals. Technological and organizational practices. Understanding the interplay between privacy and security practices is vital for privacy technologists. This includes distinguishing between data security incidents and privacy breaches, and understanding how technologies can be leveraged to support privacy through data protection measures such as encryption and access controls. Data management and compliance. Managing data through its life cycle, from collection to destruction, is a critical aspect of privacy. Technologies must be designed to ensure data accuracy, relevance, and retention limitations. Additionally, conducting data protection impact assessments, DPIAs, helps identify and mitigate risks associated with data processing activities. Conclusion. As digital technologies continue to evolve, the role of the privacy technologist becomes more complex and integral to an organization's success. Preparing for the CIPT certification empowers professionals with the knowledge to implement privacy in technology effectively, ensuring that privacy considerations keep pace with technological advancements. By mastering these foundational principles, technologists can help forge a path towards a more secure and privacy-respecting digital future. Team dynamics and leadership. Privacy technologists work within diverse teams that might include data protection officers, DPOs, chief privacy officers, CPOs, legal experts, and security specialists. Understanding the dynamics and distinct roles within this team is crucial for effective privacy management. This cohesive understanding ensures that privacy strategies are comprehensively developed and implemented across the organization. Standards and framework implementation. Adopting and implementing industry privacy standards and frameworks such as GDPR, HIPAA, or CCPA, and utilizing structures like NIST or ISO/IEC 27701 is fundamental. Privacy technologists must translate these frameworks into actionable policies that align with organizational goals while ensuring compliance. Regulatory translation and application. Translating legal and regulatory requirements into technical and operational solutions is a critical responsibility. This involves not just understanding laws but also foreseeing how changes in legislation could impact the organization's technology stack and business practices. Policy development and consultation. Privacy technologists frequently consult on the development of internal privacy notices and external privacy policies. They ensure these documents are not only compliant with current laws but also transparent and understandable for users and employees. Contractual and regulatory compliance. They play a pivotal role in interpreting contractual terms and regulatory requirements, ensuring that the organization's obligations are clearly understood and met. This often involves close collaboration with the legal department to safeguard the organization against potential legal challenges. Part B, Technical Responsibilities. Advising on privacy and security technologies. Technologists advise on the adoption and implications of existing and emerging technologies. Their expertise helps in making informed decisions about deploying technologies that align with privacy and security best practices. Implementation of privacy measures. Implementing technical measures for privacy and security, and developing privacy-enhancing technologies, are key operational duties. This includes everything from securing databases to integrating privacy design in new software. Privacy by design. Advising on privacy by design and conducting security and privacy impact assessments during system development ensures that privacy is considered at all stages of a project, from inception through deployment and beyond. Managing data subject rights. Handling requests from individuals exercising their rights under privacy laws, such as requests for data access or deletion, requires a deep understanding of both the technical mechanisms and the legal basis for data processing and privacy. Operational and compliance audits. Supporting or leading audits related to IT privacy, including third-party assessments, is essential for maintaining compliance and trust. Privacy technologists review security incidents and advise on the necessity and structure of breach notifications. Data governance and metrics. They support or manage the creation and maintenance of records of processing activities, ROPA, automating inventory systems, and mapping data flows to provide clear visibility and control over data processing activities within the organization. Additionally, developing and reporting on CRIS and KPIs enable ongoing evaluation of privacy practices and effectiveness. Conclusion. The privacy technologist's role within an organization encompasses a broad range of strategic, operational, and technical responsibilities. As gatekeepers of privacy and data protection, their work is crucial to mitigating risks, ensuring compliance, and fostering a culture of privacy that aligns with both ethical standards and business needs. In an increasingly data-driven world, the expertise of privacy technologists is not just valuable but indispensable in securing the trust and confidence of all stakeholders. Future outlook. As technology evolves and privacy concerns become more complex, the role of the privacy technologist will undoubtedly expand and evolve. Organizations will continue to depend on these professionals to steer them through new challenges and opportunities in the realm of data privacy. Legal compliance and ethical obligations. Navigating the terrain where legality and ethics intersect requires a nuanced understanding of both. In jurisdictions with less stringent privacy laws, companies face the challenge of deciding whether to adhere only to local laws or to implement higher standards that reflect ethical commitments to user privacy. This involves making decisions that often extend beyond mere legal compliance to embrace global best practices, thereby upholding the principles of fairness and respect for personal information. Moral and societal issues. The strategic use of data can have profound ethical implications, especially when it comes to unauthorized access or manipulation of information. For instance, using data to influence societal attitudes on controversial topics raises ethical concerns about the role of data in shaping public opinion. Such actions not only question the morality of data use but also the long-term effects on democratic processes and societal trust. Bias and discrimination. Data-driven decisions can also lead to bias and discrimination if not carefully managed. Algorithmic decision-making, for example, must be constantly reviewed to ensure that it does not perpetuate existing biases or introduce new forms of discrimination, thereby ensuring that automation enhances fairness rather than detracts from it. Consent and transparency. Obtaining genuine informed consent is increasingly challenging, especially with the rise of technologies that can collect data unobtrusively. Ensuring that individuals are fully aware of and understand what data is collected, how it is used, and their rights regarding that data is crucial for ethical data practices. Jurisdictional complexities. Organizations must also navigate the complexities of data localization and government access to data, which can vary dramatically between jurisdictions. This not only affects legal compliance but also raises ethical questions about the extent to which companies should resist or comply with governmental demands that might infringe on individual privacy rights. Security and privacy concerns. Maintaining the security of personal data and managing risks related to identification from aggregated datasets are paramount. Ethical handling includes ensuring that personal data is not used for secondary purposes without explicit consent, safeguarding individuals' privacy rights. Profiling and exclusion. Ethical concerns also arise with profiling practices, which if not correctly managed, can lead to exclusion or discriminatory outcomes. Organizations must consider the implications of their data use practices to prevent unintended harm to individuals or groups. Managing data disclosure. Strategies to control data disclosure and to protect against data distortion or unauthorized access are essential. Increased accessibility of data, if not properly managed, can lead to issues like blackmail or data appropriation, making robust security measures a necessity. Breaches and confidentiality. Effective management of data breaches and maintaining confidentiality are critical. Organizations must have strong incident response strategies and should be transparent about breaches to maintain trust and comply with legal standards. Advertising and cyber threats. The ethical use of data in advertising and the prevention of practices like cyberbullying or social engineering are crucial for protecting personal privacy. Organizations should also guard against dark patterns in user interfaces, which can manipulate users into making decisions against their own interests. Maintaining robust security. Effective management of software vulnerabilities, including timely updates and patches, is crucial. The choice between open source and closed source software also impacts security and privacy, requiring careful consideration of the trade-offs involved. Conclusion. Privacy risks, threats, and violations pose significant challenges in the digital landscape, demanding a proactive and informed approach to data management. By understanding the ethical, technical, and legal complexities, organizations can develop more effective strategies to protect personal information, thereby ensuring privacy and building trust with users and stakeholders. Future directions. As technology evolves, the landscape of privacy risks will also transform. Continuous education, robust privacy frameworks, and ethical decision-making are essential for navigating future challenges, ensuring data privacy in an increasingly interconnected world. Data-oriented strategies. Separate. The strategy of separation involves physically or logically segregating data to prevent unauthorized correlation of datasets. For instance, sensitive health information can be stored separately from less sensitive personal details to enhance security and reduce risk. Minimize. Data minimization refers to the practice of collecting only the data that is directly necessary for a specified purpose. This limits the risk of exposure and minimizes the potential impact of data breaches. Abstract. Abstraction reduces the precision of data to prevent the identification of individuals. By aggregating or otherwise reducing the resolution of data, organizations can use information for analytics without compromising individual privacy. Hide. 1. Concealing data through techniques such as encryption or tokenization ensures that personal information remains hidden from unauthorized viewers, securing it against breaches and unauthorized access. Part B. Process-oriented strategies. Informing the individual. Transparency is key to privacy protection. Organizations must keep individuals informed about data collection practices and processing activities, thus upholding transparency and building trust. User control. Empowering users with control over their data is fundamental. This involves providing mechanisms for individuals to access, correct, and delete the data, as well as control how it is used. Policy and process enforcement. Effective privacy management requires robust policy enforcement. Organizations must ensure that all data handling practices comply with both internal policies and external legal requirements. Demonstrate compliance. Regular demonstrations of compliance through audits and assessments reassure stakeholders and regulatory bodies that privacy is being taken seriously and managed properly. Part C. Privacy-enhancing techniques and technologies. Aggregation and anonymization. Techniques like aggregation and anonymization remove identifying details from data, rendering it unusable for anyone who seeks to exploit personal information. Pseudonymization and encryption. Pseudonymization replaces identifiers with pseudonyms, whereas encryption secures data by making it unreadable to unauthorized users, both essential for maintaining privacy. Identity and access management. Robust identity and access management systems ensure that only authorized individuals can access sensitive information, critical for preventing data breaches. Technology for compliance. Technologies that facilitate compliance with privacy regulations include automated systems for managing consent, performing privacy impact assessments, and handling privacy incident reporting. These tools help organizations stay compliant and respond swiftly to potential privacy threats. Conclusion. Employing a multifaceted approach to privacy enhancement not only helps organizations meet regulatory requirements but also builds a strong foundation of trust with consumers. As data breaches become increasingly common and costly, the implementation of advanced privacy strategies, techniques, and technologies is more important than ever. Organizations that proactively manage and protect personal data are better positioned to succeed in a competitive, data-driven marketplace. Future directions. Looking ahead, organizations will need to continually adapt and refine their privacy strategies to keep pace with technological advancements and regulatory changes. Staying informed about the latest privacy-enhancing technologies and maintaining an adaptable, proactive privacy management approach will be key to navigating the future of data protection. The role of privacy engineering in organizations. Effective implementation. Privacy engineering plays a pivotal role in the effective implementation of privacy policies and technologies within an organization. This includes translating privacy requirements into technical specifications and ensuring that these requirements are integrated into all phases of system development. Technological controls. Privacy engineers are responsible for identifying and deploying appropriate technological controls to safeguard personal data. This involves implementing security features like encryption, access control, and other methods to ensure data integrity and confidentiality throughout its lifecycle. Protecting privacy during the development lifecycle. From the initial design to the testing and deployment stages, privacy engineers ensure that privacy considerations are integrated at every step of the development process. This proactive approach helps prevent privacy vulnerabilities from being embedded into systems and software. Privacy engineering objectives. Predictability. One of the main objectives of privacy engineering is to create systems that behave in predictable ways regarding data handling. This predictability helps in maintaining user trust and compliance with privacy regulations. Manageability. Privacy engineers strive to design systems that allow both users and administrators to manage privacy settings and controls easily. This includes providing clear options for users to control their personal information and for administrators to adjust settings as needed to comply with legal requirements. Disassociability. Ensuring that personal data can be disassociated from specific individuals is another key objective. Techniques such as anonymization and pseudonymization are used to achieve disassociability, thus enhancing privacy protection. Privacy design patterns. Design patterns. To emulate privacy engineers should follow established design patterns that promote privacy, such as minimal data collection, data minimization, and ensuring that privacy settings are accessible and understandable to users. Dark patterns. To avoid it is also crucial to avoid dark patterns that mislead or trick users into giving away more personal information than they intend. Privacy engineers must ensure that designs are transparent and foster an honest user interaction. Privacy risks in software. Controls and countermeasures. Privacy risks in software can be mitigated by implementing robust controls and countermeasures throughout the development process. This includes conducting regular privacy impact assessments, employing secure coding practices, and performing privacy audits and code reviews. Privacy by design methodology. Testing and validation. Privacy by design methodologies advocate for rigorous testing and validation of privacy measures before software or systems are deployed. This ensures that privacy functions operate as intended and that any potential leaks or breaches can be identified and rectified. Part B. Privacy interfaces and user experience. Design effects on user behavior. The way privacy interfaces are designed can significantly affect user behavior. Good design should encourage privacy-friendly user actions and enhance the overall usability of privacy-related functions. Usability of privacy-related functions. The user experience (UX) design plays a crucial role in the usability of privacy settings and consent management systems. Well-designed interfaces make it easier for users to understand and manage their privacy preferences effectively. Ongoing vigilance. Continued vigilance is essential in privacy engineering. This includes regular audits, code reviews, runtime behavior monitoring, and updating systems to respond to new threats. Data cleansing practices in both production and non-production environments also help maintain data integrity and privacy. Conclusion. Privacy engineering is a vital discipline within modern organizations, tasked with bridging the gap between legal compliance and ethical privacy practices. By integrating privacy from the inception of the design process and maintaining vigilant oversight, privacy engineers play a crucial role in protecting user data and building trust. As technology evolves, the role of the privacy engineer will continue to grow in importance, necessitating continuous education and adaptation to new privacy challenges and solutions. Future directions. The field of privacy engineering will continue to evolve as new technologies emerge and as the privacy landscape changes. Ongoing education and adaptation to these changes will be crucial for privacy engineers seeking to effectively safeguard personal information in an increasingly interconnected world. Part A: Robotics and Internet of Things, IoT. Mobile phones and wearable devices. Mobile phones and wearable devices are at the forefront of collecting vast amounts of personal data. From health monitoring apps to location tracking, these devices raise significant privacy concerns regarding the vast amount of sensitive data they gather. Edge computing. Edge computing processes data at the edge of the network, nearest to where it is generated. While it can potentially enhance privacy by reducing the amount of data sent over the network, it also introduces new challenges in securing these edge devices from unauthorized access. Smart homes and cities. Smart homes integrate technology into personal living spaces, while smart cities use IoT devices like CCTV and tracking systems to manage urban environments. Both pose significant surveillance and data security challenges, requiring robust privacy protections. Robots and drones. Robots and drones are increasingly used for personal and commercial purposes. As these technologies collect and interact with personal data, they pose unique privacy risks that must be managed with specific controls and regulations. Part B: Internet, e-commerce. Ad tech and web tracking technologies. Advertising technologies, including cookies and other tracking mechanisms, are pervasive in e-commerce. They track user behavior across the internet, raising issues of consent and personal data security. Alerts, notifications, and location tracking. Services that utilize location tracking and send alerts or notifications based on user activity must navigate the thin line between providing personalized services and infringing on privacy. Chatbots and online, mobile payments. Chatbots interact with users, often processing sensitive personal information. Similarly, online and mobile payment platforms handle crucial financial data, necessitating high levels of security and privacy compliance. Part C: Biometrics. Facial, speech, and fingerprint recognition. Biometric technologies are increasingly common, used for everything from unlocking devices to identifying individuals in public spaces. While they offer security benefits, they also raise significant privacy concerns, especially if biometric data is compromised. Behavioral profiling. Techniques used to monitor and predict behavior based on data analysis must be carefully managed to avoid intrusions into personal privacy and potential discrimination. Part D: Corporate IT services. Shared data centers and cloud-based infrastructure. The shift to cloud-based solutions and shared data centers has centralized massive amounts of data, creating targets for cyber attacks and raising issues of data sovereignty and control. Remote working and video conferencing. The rise of remote working has increased the use of digital communication tools like video calls and conferencing, which require new levels of data protection and user privacy safeguards. Part E: Advanced computing. Artificial intelligence and machine learning. AI and machine learning analyze large datasets to predict patterns and behaviors. Privacy concerns arise from how data is collected, used, and stored, and the transparency of these processes. Blockchain and cryptocurrencies. While blockchain presents opportunities for security enhancements, it also poses privacy risks, especially in how transaction data is managed and accessed. Quantum computing. The potential for quantum computing to break current encryption methods could drastically change the landscape of data security, requiring new approaches to privacy protections. Part F: Social networks. Social media and messaging. Social networks collect extensive data on user interactions, preferences, and personal networks. Managing this data responsibly is crucial to protect individual privacy. Virtual, augmented reality. As these technologies create immersive experiences, they also capture a high volume of sensitive personal data. Ensuring this data is handled with respect to user privacy is paramount. Conclusion. Emerging technologies present exciting opportunities but also significant privacy challenges. Organizations must proactively engage with these technologies, ensuring that privacy considerations are integrated from the design phase through implementation and beyond. By adopting a robust privacy by design approach, organizations can safeguard personal data and navigate the complexities of modern technology landscapes. Future directions. As technology continues to evolve, so too will the strategies for managing privacy. Staying ahead of technological advancements and regulatory changes will be key for organizations aiming to protect personal information and maintain user trust in an increasingly digital world.